This is Note-Taking Guide 12.4. Today we're going to find the inverses of 2x2 matrices. Again, we can find inverses of bigger matrices, but for our purposes in this class, we're just going to do it by a 2x2. So last class, I taught you how to find the the determinant of a matrix. And in order to find the inverse, we're going to do the same thing here. If you notice, to find the inverse of a matrix, we actually do 1 over the determinant value, and then we times it by a matrix that is a little bit different. So we normally have A and D right here. We flip them spots, and then we change the signs the other direction. So 1 over the determinant, flip this direction with the diagonal, and change the signs on this direction. So let's see if we can do that. So the first thing we have to do is find the determinant. So our determinant is going to be -4 times 9, this direction, minus 0 times 3. So when we multiply that, oh, that's not looking like a multiply sign. I'll just put some parentheses in there, I guess. This will be a -36, and then it would be minus 0. So -36 is my determinant. So the rule said I go 1 over my determinant, and then I'm going to times it by my matrix that I flip. So I change these two positions. So this will be 9, and this will be -4. And then I change the signs on these two. Well, 0 doesn't have a positive or negative sign, so it stays 0. But this one becomes -3. And then what I have to do is multiply this scalar through every part of the matrix C. Okay, so I'm going to do 1 over -36 times 9. And if we do that on our calculator, it will totally reduce it for us at the same time. So I'm going to do 1 over 36 on my calculator and then times it by 9. And don't forget the negative there, so it's going to be a -1/4. Then I'm going to do the same thing with this -3 right here, times it. So do -3 times on your calculator 1 over 36. And make sure you put a negative on that. You get a -1/12. Actually, I should get a positive 1/12. Sorry, I must have punched that in my calculator wrong. Because the negative times the negative right here is going to give me a positive. I would have 1 over -36 times 0, which is going to be 0. And then 1 over -36 times 4, which should be a positive 1/9. So this is actually my inverse matrix right here for that matrix there. So again, what I did was I found the determinant, and then I did 1 over the determinant, and then I changed the positions of these two and changed the signs on those two. Let's give it a try one more time. The first thing I have to do is find the determinant. So 6 times 8 minus -1 times 5. So 6 times 8 is 48, and then this would be a positive 5 back here. So my determinant is 53, which is kind of an ugly number, but in a way it kind of makes it nice because it means it probably is not going to reduce with anything. And then when I change my matrix around here to multiply by. So I'm going to put 8 up here and 6 down here, and then I change the signs on these. So if this is a -1, it becomes a positive 1. And that was a positive 5, so it becomes a -5. And then I just multiply through by that 1 over 53 out front. You can totally just let your calculator do this. So 8 times 1 over 53 is 8/53. -5 times 1 over 53 is -5 over 53. 1 times 1 over 53 is 1/53. And then 6 over 53 would be your last answer. So really ugly, but that would be our inverse matrix right here. This would be my solution. All right, I think we have 2 more examples here. Let's see what happens. Right here on my determinant, I'm going to do 2 times -3. And then over here, I have 2 times 3. So this multiplies to a -6. This is a -6. And -6 minus 6 is a -12. So I would do 1 over -12. And then I'm going to flip these two. So it becomes a -3 up here and a 2 down here. And change the signs on the other two. So they were both positive. I make them negative. And then I'm going to punch this on my calculator as I go so that it will just spit out the reduced number for me. So a negative 3 times a negative 1/12 would be 1/4. A negative 3 times a 1/12 negative would be 1/4 again. Negative 2 times a negative 1/12 would be 1/6. And then if this one's positive 1/6, this one's going to be negative 1/6 because only the sign changed on it. So again, my solution to that problem. All right, one more here. We have 0 times negative 6, which is 0. And we're going to subtract from that 4 times negative 4 times 5. So I get 0 minus 20. Actually, minus a negative 20, which is going to make that a positive 20. So out front, I have 1 over 20. I changed the direction of my matrices. This changes signs, that one changes signs, and I multiply through by. Again, do it on your calculator so it will reduce for you. So when you do that, you get negative 3/10. You get 1/5, negative 1/4, and 0 for your values there. Good luck with your homework.